Good morning, all of you.
Good morning, sir.
Right. So up to
Good
now,
morning, sir.
good morning. Let's continue from last lesson. We have stopped at the singing fund. Today we will discuss from this slide number 21, capital recovery and loan amortization. Right. Capital recovery, right? So normally we get a loan to purchase a vehicle or house or whatsoever we need. So we repay the loan in installment basis. The installment consists of both the principal amount plus interest. Right? This interest is already the percent rate of interest is already determined by the bank or the provider of a fund loan, and the installment is depends on the number of periods and the amount we have received. So to determine what is the installment, monthly installment or annual installment, so that's a formula, right? This is the formula. Right, we will continue that. So capital recovery is the annuity of an investment made today for a specified period of time at a given rate of interest. Here there are two things. The first specified period of time, right, and the rate of interest. So those two things determine the amount of installment. Capital recovery factor helps in the preparation of a loan amortization, a loan repayment schedule. It's a table, right? So normally when we decided to buy a car through leasing, the banker, the leasing provider will give us a chart, right? He will give a chart. This chart depict as how much amount of installment from this installment, how much what's the portion of interest, what's the portion of principal amount, so that sort of things. And okay, some people say voice is not clear, right? And so this is the formula. A is the installment, right? Annuity. A is the installment. P is the principal amount. the amount of loan you are expected to receive into 1 over PVAF, future value, sorry, present value annuity factor. N is number of period and I is the rate of interest. So in simple term, we say A, annuity installment equal principal amount into capital recovery factor. The capital recovery factor is this here within the bracket, right, in the above formula. People says sound is not clear. I can change the mic. Right. Right. Is it now? Is it clear? Right. The reciprocal of the present value annuity factor is called as capital recovery factor. So this is called as capital recovery factor, CRF, 1 over present value of annuity factor, right? Then loan amortization schedule. Here, so this is the 3 years plan, 3 years loan amortization schedule. So this is year 0. 0 mean the end of year 0 means beginning of year 1. Beginning of year 1. So we have taken loan 10,000 and the installment is 3,951, right? This is an installment. And so this installment consists of two things. The first one is interest. The second portion is principal repayment. Then we have to deduct here. This is the 10,000 is the capital amount, outstanding amount. So we have to deduct from this principal, not interest. We not deduct all 3,951, right? So we have to deduct the principal payment of 3,051. So 10,000 minus 3,051 equal 6,949 rupees. This is the outstanding balance at end of year 1. And then again end of year 2, see the same amount of installment, right? Equal amount of installment, and this consists of 625 rupees as interest and 3,326 is the principal repayment. And to find out the outstanding balance, here 6,949 is the balance at beginning of year 2. Then principal repayment made in year 2002, year 2 is 3,326. Then this value minus capital repayment equal 3,623. Likewise, in the year 3, same amount of repayment of installment. It consists of interest of 326 rupees, and the capital repayment is 3,625. Then is balance, right? So it should be equal amount. Then so how do we got this value 3,951? How do we got this value? How do we got this value? So we have taken loan 10,000 for 3 years, and based on the formula, we have found out that 3,951. So how do we get it? Isuru, how? How do we got this value 3,951 as installment? Isuru? Why is it not clear? Is it clear now? Is it clear? Isuru, is it clear? No one, no one speak out. Pavitra, can you hear? Madhuchanga, can you hear? So what to do? If voice is not clear, what to do? What we can do? Wait, I will test. Hmm, microphone. Can you hear my voice? Is it audible to you all?
But sometimes
So that's
sometimes it gets stuck.
a problem of poor network connection. So it's out of our control. Anyhow, I will send the recording. Right. Uh, and also my mouse pointer also get delay, no? I think.
Yes, sir.
So that's a thing. All right.
Yes, sir.
Yeah. So, Isuru, how do we find this value 3,951 as a installment? Any idea? Right. In the previous example, uh, right here, this is the question. Suppose you have borrowed 3 years loan of rupees 10,000 at 9% from your employer to buy a motorcycle. If your employer requires 3 equal end of year repayment, then annual installment will be this. So we will do in Excel. I think last class also we have done this. right? We have right. We have found that in the last class at the future value is 10,000. Interest is 9%, and number of periods 3. Then we have to find out the annuity. So according to the formula, we have found out that PVF is 0.77 and 1 minus PVF. So this is the formula I have explained, in the last class to find out the present value of interest vector annuity. So first we have to find out the present value, then we have to deduct that present value from 1. Then we have to divide the value by rate of interest. Then we will get present value interest vector annuity, right? Then we have got taken the present value interest vector annuity is 2.53 129 right? Then according to the formula, uh, the loan amount is 10,000, right? The loan amount is 10,000, and the future present value of interest vector annuity is 2.53. Then so we take this value by dividing 10,000, that's a principal amount, divided by present value interest vector annuity. Then we taken the value of 3,950.54, right? This is the installment. Over the 3 years period we have to pay this amount, right? Now we will prepare the plan, right? Does this screen is visible all of you? Excel sheet, is it visible? Is it visible, Excel sheet?
Yes,
Okay,
sir.
okay. Then right, yeah, year we have to put year, right? Then installment and interest, installment, interest, and yeah, principal. Uh, principal amount. Principal repayment, right? Right. Right here, beginning of year 1, that's called 0. The end of year 1, end of year 2, end of year 3. So according to the calculation, we have identified that the installment. Annual installment is 3,950, right? Annual installment is 3,950. Sorry, at the end of the year 0, at the beginning of the year, you are not paid installment, right? You're getting loan amount of 10,000, right? This is the outstanding balance, right? This is the outstanding balance. So at the beginning of the year 1, right? But you pay installment at end of first year. First installment will be paid on end of year 1. So then the installment is 3,950, right? So interest, how do we find interest? How we can find interest? So for 10,000, right? Our amount is 10,000, and rate of interest is 9%, 0.9, right? 0.9. Then how much? 900, right? Interest is 900, right? Interest is 900. How do we calculate it? So outstanding balance is 10,000 at the rate of 9%. Here, at rate of 9%, that is equal 900, right? So that's amount equal, interest equal 900, right? Interest equal 900. And principal payment, right? Here, all total installment is 3,950, right? And from this value, interest is another component, and right, then we can find the balance is 3,050. Then how much outstanding at end of the year one? So this outstanding balance at beginning of year one, and we have paid the principal amount installment 3,050. Then we take right now, this is the new outstanding balance, right? Again, we have to pay same installment, right? End of the year two, right? End of the year two, we have to pay installment 3,950. From this installment, there are two things. One thing is interest. Another thing is principal repayment. Two components: principal and uh, interest. So first we have to find out the interest. How do we find interest? It's a simple, right? Simple. Equal, this is the outstanding balance, into 9%, 0.9%. How much? 625, right? So this amount will be considered as 625 is a interest. Then capital repayment equal, so we have to deduct this installment interest from the installment. So we deduct the interest 3,325. Uh, this is the principal repayment. Again, we calculate outstanding balance, right? So this is the outstanding balance at the end of year one, and we paid during the period as installment is 3,325, right? Minus this value. Then next year we paid how much? Outstanding balance 3,624. Again, our installment is equal, right? In same installment, and we have to find out the interest. So this is the outstanding balance into the interest is 0.09%. That is 326. The interest. And now we calculate the principal payment, prepayment. This is the installment. We deduct interest and 3,624. Then outstanding balance equal outstanding balance at end of year 2, deduct installment paid, sorry, capital repayment paid during the period is 3,624. Balance, see, right? So this is the loan amortization schedule, right? Any questions? Any questions? Pavitra? Pavitra, where? You know that. Dylan Madhusanga? Pavitra? You unmute your mic and tell your comments. Is it clear? Oh, right. Anyhow, uh, right. So this is how the figure has been calculated. Loan amortization schedule has uh, developed. Then we will move to the next. Right. Present value of uneven periods, peak sum, right? So up to now we have discussed circumstances like we pay the same amount of money we deposit, or right, we pay or deposit the same amount of money in the same interval period of time. That's why we have calculated annuity, right? So it is all the times it is not practicable, right? All the times. So sometimes we pay 3,000, so next month we pay 2,000, 2,500, 5,000. So based on our ability, right? We deposit our money to the bank. We So this time, how do we calculate the present value of uneven periodic sum? Uneven, not equal, right? Uneven periodic periods. Right? We can apply the annuity formula. In most instances, the firm receives a stream of uneven cash flows, right? Thus, the present value factor for an annuity cannot be used. The procedure is to calculate the present value of each cash flow and aggregate all the present values. Means we have to find out the uh, present value factor manually. Like here, example, consider that an investor has an opportunity to receiving 1,000 rupees, 1,500 rupees, 800 rupees, 1,100 rupees and 400 rupees respectively at end of 1 through 5 years, right? The first year he will get 1,000, second year 1,500, third year 800, like that. Find out the present value of this stream of uneven cash flows, right? This is the example, right? In addition to that, they have given us information on rate of interest. The investor's required rate of trade is 8%. The present value is calculated as follows. I will do in Excel, right? So if anybody are facing difficulties to in understanding the explanation, please stop me and ask questions. Right, this is the question. This is the question, right? Right. Um, right here, year, right, years come from 0, 1, 2, 2, 3, 4, 5, right, here. Then cash flow. Cash flow and present value, PVIF, present value interest factor, and present value, right? And end of year one, uh, rupees 1000, right? Deposit rupees 1000. End of year 2, 1500. End of year 3, 800. And end of year 4, 1100. End of year 5, 400, right? So in this way he has deposited, sorry, in this way he has received money, right, for the next 5 years. Then we have to find out here the present value interest factor, right? We have to convert these future values into the present value. To convert future value into present value, we have to discount the cash flows. To discount, we are using uh, PVIF, present value interest factor, right? So to calculate, what we have to do is 1 over, right? 1 over 1 plus R, 1 plus R. In this question, the rate of interest is 8%. Therefore, 0.08, right? Here, the number of period is 1. So, therefore, we put 1, right? Likewise, right? Right? Clear? Clear? Don't be silent. So, when I ask questions, please tell your comments. If you are not clear, say not clear, right? And here, then we just put equal sign, then we will get the present value interest factor, right? Now we can find the present value. Cash flow 1000 rupees into present value interest factor annuity is 0.925. Therefore, the present value is 925. Likewise, cash flow 1500 into present value interest factor, right? Likewise, 800. 800 is the cash flow, and present value of interest factor is 0.793. Therefore, 600. Likewise, we have to apply the same principle to all rest of the years. Right now, equal sum. Sum means, so this value plus this value plus this value plus this value plus this value. So the present value of future cash flows, uneven future cash flows, is 3,927. Right? You check the answer. How much? 3,927. 3,927, right? So the way of doing the sum is correct, right? So this is the answer, right? You got the same answer, right? 3,927. Here also we get 3,927, right? So in this slide, the answer, the way of finding answer is different, right? So in Excel, we have done in different way, right? So you can adapt. So whichever method easy for you, right? Right. Any questions? Any gray areas we can ask, right? Then we will move to the present value perpetuity, right? It's the important word. We will use the word perpetuity frequently in forthcoming lecture series, right? Perpetuity means perpetuity is an annuity that occurs indefinitely, right? There is no maturity. There is no maturity. We can't find the word called uh, for 5 years, 10 years, mature in 5 years, mature in 20 years. We can't find that kind of things, right? It's mean there is no definite defined period of time, infinity, right? Perpetuity means infinity. Perpetuities, perpetuities are not very common in financial decision making. So in practical, we couldn't find this kind of scenarios here. The present value of an annuity is the present value of a perpetuity equal perpetuity divided by rate of interest. Uh, we have to divide the amount of money you're willing to invest it or received for infinity period of time and divided by a rate of interest. So for example, assume that you will get 10,000 rupees every year, right? Every year, but you don't know what is the maturity period, right? Every year, your lifetime, until you live, you will get the same amount at end of every year, right? So this is called perpetuity, right? So we can't estimate how many installment we will get. Or you deposit 5,000 end of every month, end of every year, for infinity period of time. It's called in perpetuity. There's no ending period, right? There's no maturity, right? The to calculate the present value of an perpetuity is very simple, right? We have to divide the amount of installment or deposit value and divided by rate of interest. Let us see one example for perpetuity, right? Let us assume that an investor expects a perpetual sum of rupees 500 annually from his investment, right? Say for example, Mr. X, he has deposited or he has made an investment and due to that investment he will receive continuously 500 rupees every year, end of every year. Which means there is no maturity, right? He don't know how many years he will receive this money. So what is the present value of this perpetuity if his interest rate is 10%, right? So as I told you earlier, the calculating present value of an perpetuity is very simple. Here, the value of perpetuity is 500 divided by 0.1. Here, look carefully. Normally, to calculate PVIF, we put 1 plus R. But in case of perpetuity, we are not consider 1 plus. We put only R value, 0.1, 10%, right? So the value of the present value of that perpetuity is 5,000. And the present value of growing annuities, it is not in your syllabus, so we will just ignore this slide. Right, it's very important. Value of an annuity due. Is due mean, so most of the cases we are considering that cash flow occurs end of each year, right? Cash flow occurs end of each year, right? End of each period. So this is the common case, but sometimes uh, we have to the cash flows occurs beginning of the period. Cash flow occurs at beginning of the period. Say for example, normally for the leasing, if you are taking a loan to purchase anything, sometimes called car or whatever, you have to pay installment end of every year, end of every month, right? That is normally it's an annuity. But if the cash flow occurs at the beginning, say every January, every 1st of January, right? Or beginning of every month, beginning of every year. So like that, it's called due, right? Due means earlier, beginning, right? Beginning. Annuity due is a series of fixed receipt of payment starting at the beginning of each period, right? At the beginning of each period for a specified number of periods. So future value of an annuity due, so very simple, don't make it harsh with you, right? Here, future value, right? So its normal formula is installment annuity, right? Annuity into cumulative factor, uh, so compound value factor annuity, compound factor annuity. You just do it additional work 1 plus R. You have to multiply this value by 1 plus R. Same thing, same principle will apply for the present value too, right? You just find the value and you just multiply by 1 plus I, 1 plus R. Very simple. Don't make it harsh with you, right? See the example, right? See the example. When you deposit rupees 1 at end of each year, the compound value at the end of fourth year is 4.375, not so, rupees 4.375. However, rupee deposited in the beginning of each year 1 through 4, you will earn interest respectively for 4 years, 3 years, 2 years, 1 year, right? Right, I will explain in another example, right? New example. right? Annuity due, right? So normally the cash flows occurs, right? Occurs end of. Now we will consider annuity due year 0, year 1, year 2, year 3, year 4, like that, right? And cash flow, right? Normally, annuity means cash flow starts on year 1. Say you deposit every year 1,000, 1,000, 1,000, 1,000, like that, right? So annuity due mean you start to the cash flow start beginning of year 1, right? So you will receive here, right? Then you are not receive cash end of year 4, right? So 0 mean beginning of year 1, here, beginning of year 2, beginning of year 3, beginning of year 4, right? Clear? And assume that rate of interest is 10%. Rate of interest is 10%. Assume that we do without due. First we will do without due, 1,000. So what is the present value factor? Oh, let us future value. We'll do a future value, right? So what's the future value? 1 plus 0.1 into year 1, right? Like this, right? Then we will find the future value. Then you will receive this amount into this amount, likewise, right? So total value you will receive equal sum 5,105, right? Is it clear? If you are clear, only I can move forward to next. This is not a annuity due. This is normal annuity, right? I will explain based on this example. Any queries? Any queries, please? Any queries? This is normal way as we did earlier, right? And so we have calculated. So we have calculated this future value factor one by one, right? One by one. So we already know. So annuity, if we are getting the same amount in the same interval we can apply annuity, right? We can apply annuity. So simply, so we can apply annuity formula. So that annuity formula is uh, n plus r and right. Um, right. Again, so it is normal annuity, right? It is normal annuity. Now we will do it for annuity, right? This is not an annuity due. So we will look at annuity due. Annuity due means here all are same, but we have to make this cash flow here at the year one, beginning of year one. It means here 1000. This is beginning of year two, beginning of year three, beginning of year four, right? So therefore, there is no cash flow here, right? Then here, uh, right here, you will receive interest for how many years? For this value, 4 years, right? Say for example, this is year 2000. This is 2001, 2002. This is 2003, 2004, right? If you deposit January, you deposit on January 2000 of rupees 1000 rupees, for how many years you will get interest for this value, for this amount? You will get interest all year 2000, right? And you are going to withdraw this money in year, withdraw this money end of beginning of not end of year 2004, right? So you will receive interest for 4 years for this value, and you will receive interest for 3 years for this value, and you will receive interest 2 year, oh, yeah, 4 years, 3 years, 2 years, and 1 year, right? There is this year there is no uh, there is no uh, cash deposits, right? Then here how you can calculate. For this value you can get interest for how many years? 4 years, no? This value equal this value into 10%, right? Interest. For this value you will get interest for 3 years. For this deposit you will receive interest for 2 years, and for this value you will get interest this year. There is no investment, right? There is no investment. Then how much you will receive for this value? Equal right. Then how much? Equal amount we receive, no? So rather than doing one by one, we can use the annuity formula, future value of an annuity. So that is, we can write normal formula is 1 plus R over N minus 1. So I use a formula, it's like this. Here, future value of an annuity. This is right, this formula. So this is the formula. Every year he deposit 1,000, right? Every year he deposit 1,000 for how many years? Equal 1,000 number of years. In this example, 4, right? And rate of interest 10%, and is annuity due, right? So type is due. First we will do without due, right? Without due. Without due, how do we calculate? So we apply this formula. 1 plus R is 0.1, number of years, 4, right? 4 minus 1. Again, we have to divide by R, that is 0.01. So this is future value of an annuity. 4.461. 4.461. This is future value of interest vector annuity, right? This value called future value interest vector annuity, right? So according to the formula, so it is without due. Without due means the cash flow occurs at end of each year, right? Then the future value is 1000 into this value 4.641, right? So the answer is 4641 rupees, right? This is without due. Without, okay. In case if it is a with due, right? It's an annuity due. So what we have to do is we have to multiply by r, 1 plus r. So according to the formula here, first we have to find out PVIFA, right? And we multiply by 1 plus r. Simply what we have to do is this value, right? This value into 1 plus r. 1 plus r is 0.1, right? So Annuity Due is 5,000, 5,105, right? Plus r, right? And the same principle will be applied for the present value, right? So we have to find out the present value of interest vector annuity. Yeah, present value of an annuity, the same thing. Okay. Annuity into present value of interest vector annuity into 1 plus r. So what we have to do is what we have to do. So we have to find out PVIFA, right? PVIFA. All the informations are same. So every year we will receive 1,000 for 4 years at 10%, right? First we will do without due, right? First we will do without due. Without due, you know the formula. We will use this formula. We will use this formula, right? We will use this formula, and here first we have to find out 1 plus Rn. 1 plus R is 0.1, right? And number of years here 4, right? Number of years 4. Then we have to divide this value 1 over, right? 1 divided by this value. Again we have to, right, first we will find out the, this is the present value, right, vector. Then we have to deduct this value from 1 minus. This is 1 minus value. Right? Again, we have to find, we have to divide this value by 0.1. That's R. Right? So future value, sorry, present value in respect to annuity is 3.1968. So the same example, you will receive 1,000 every year, end of each year for 4 years at rate of 10%, right? Without due, the normal annuity, right? So we can find A equal 10,000, so 1,000, A equal, should be 10,000, I assume that, so, okay, not 10,000, 1,000, right? Every year he will receive 1,000. Every year he will receive 1,000. So end of each year, and now we can find out the uh, future value, present value equal is A into this, right? So 3,169.8. This is present value, right? This is a present value of cash flow, right? This is annuity, right? Without due, right? So new case is with due. Annuity due means what we have to do is we have to take this value, right? This is the value we have taken. This is the value we have taken by using this formula. So then what we have to do is take this value into 1 plus R. 1 plus 0.1. Simple. 4,800, so 3,486, right? So without due, it's a normal cash flow. It means end of each year. So without due mean the cash flow occurs every year, end of every year. Annuity due mean the cash flow occurs beginning of each year. This is end of each period, right? So this is beginning of each period, right? This is end of each period. This is, so end of each period mean without due, right? It's normal. It's a normal annuity. Normal annuity, right? And annuity due means the cash flow occurs beginning of each period, right? The cash flow start from year zero. Cash flow start from year zero. So this cash flow start from year one, right? Here, year one. So this is due. Cash flow start from year zero. This is not a due, without due, right? Cash flow start. There's no cash flow at beginning of the each period, right? So, right. Then we will move to next power cut, I think. Future value of an annuity example, 4.375.